Lesson 10.4, Radical Equations. A radical equation is an equation that contains a variable in the radicand. Here are the steps to solving a radical equation. Step number 1, isolate the desired variable on one side of the equation. Step number 2, square each side of the equation to eliminate the radical. And step number 3, you will simplify if possible. Okay, let's practice this skill. Number 1, radical a plus 5 plus 7 is equal to 12. So, the first thing we need to do is isolate the radical expression that contains our variable. So I want to isolate this entire expression. In order to do that, I need to remove 7 from both sides of my equation. So let's go ahead and subtract 7 from both sides. Bring down radical a plus 5 is now equal to 5. Now, in order to undo that radical symbol, what we need to do is we'll need to square both sides of our equation. And so when we square radical a plus 5, we're left with a plus 5. And when we square 5, we get 25. Now go ahead and isolate a. We can subtract 5 from both sides so that a equals 20. It's extremely important to always go back and do just a quick mental check by substituting 20 back into your original equation to make sure that that is a true solution. So let's do that. If I substitute 20 back into my radical expression, I have radical 20 plus 5 plus 7 equals 12. Well, we know that 20 plus 5 is 25, plus 7 is 12, radical 25 is 5, plus 7 is 12, and it checks. Okay, let's go on to number 2. Copy down number 2. Radical c minus 3 minus 2 is equal to 4. So again, I want to isolate that radical expression, radical c minus 3. So I'm going to add 2 to both sides of my equal sign. And I'm left with radical c minus 3 is equal to 6. And once again, in order to get rid of the radical symbol, I need to square. Whatever I do to one side, I have to do to the other. So I'm going to square both sides. And I'm left with c minus 3 is equal to 36. I'll add 3 to both sides. And so c equals 39. Again, it's important for you to go back and plug 39 back into the original equation up here to make sure that that is the correct solution and that it's a viable solution. So let's do that. Radical 39 minus 3 minus 2 equals 4. Well, this is radical 36 minus 2 is 4. Radical 36 is 6 minus 2 is 4, and it checks out. Okay. Number 3. Again, I want to isolate the radical expression, radical h plus 1. So I'm going to remove this 4 since it's positive. I'm going to do that through subtraction, subtracting 4 from both sides of my equation. So I'll bring down radical h plus 1 is equal to 10. And then in order to get rid of that radical symbol, I have to square both sides. So let's do that. And I'm left with h plus 1 equals 100. I'll subtract 1 from both sides, and so h equals 99. Go ahead and do a mental check and make sure that that is a viable solution and that is correct. Okay? Write this down, please. Extraneous solutions. Extraneous solutions are sometimes produced when n, and I'm sorry that this is, I have a keyword missing here, when an equation is squared on both sides. These extraneous solutions are not solutions to the original equations. Therefore, you must check, I'll repeat that, you must check all solutions in the original equation. It's important because sometimes when you're solving these, you will produce solutions that do not make sense. They don't work. And so we won't count them as a solution. Okay? All right, let's go on. Okay, let's look at this one. Number 4. Radical k plus 1 is equal to k plus 1. Can we change this? Let me change this. Let's make this k minus 1. So instead of plus 1, this is going to be a minus 1. All right, let me rewrite it. Radical k plus 1, here's how I want it to be, is equal to k minus 1. All right, so first step is going to be to square both sides of the equation to get rid of the radical k, the radical symbol around k plus 1. Okay, so when we square these, here I have k plus 1 is equal to, and remember that we know how to square a binomial using the perfect square pattern. So it's k squared. We'll have positive 1 here, square the first term, square the last term, multiply the two terms, k times negative 1 is negative 1k, double it, it's negative 2k. Okay? Right, now what we need to do is, we're solving a trinomial, we need to make this equation equal to 0. So, let's do this. Let's subtract k and subtract 1. And we'll do the same on the other side. We'll subtract k and we'll subtract 1. So on this side, we're left with 0 equals. Here we bring down k squared minus 3k, and the 1's cancel each other. So how am I going to solve for k? Well, I can factor the GCF here. If you notice, k squared and negative 3k have a k in common. So I can factor out the k, and I'm left with k minus 3. Now, if k times k minus 3 is equal to 0, we know there are two possibilities. K is equal to 0, k minus 3 is equal to 0, in which case k would equal 3. So, in this problem, we have come up with two solutions, but we must first check them in our original equation to see if we have an extraneous one or not. So let's go ahead and plug in. This is not optional. This is not a step that you're going to take, oh, I'm going to check my work. You have to go back when you get more than one solution. You have to go back and check to see if one of them is extraneous or not. Okay, so let's try this, and I'll do it in a different color so that you know that I'm checking my first extraneous solution. So I'm going to plug in 0 for k first. I'll try that. So I get radical 0 plus 1, which is 1, is supposed to equal 0 minus 1. Radical 1, the square root of 1 is 1, equals negative 1. Is that true? And the answer is no. So this is an extraneous solution. Okay, now let's check the other one. I'll do this one in orange. All right, we'll plug in 3. So we get radical 3 plus 1, which is radical 4, is supposed to equal 3 minus 1. Well, radical 4 we know is 2, is supposed to equal 3 minus 1, which is 2. That one checks out. So our solution is simply k equals 3. K equals 0 was extraneous, so we throw it out. We do not count that as a solution. Okay, let's go on to number 5. Number 5. Radical t plus 5 is equal to t plus 3. Let's start by squaring. Whoops, sorry about that. Squaring both sides of my equation to get rid of the radical symbol. Okay? So here we go. This is t plus 5. And again, we can use the pattern that we've learned so well, we know so well. This would be t squared plus 6t plus 9. Now we need to make this equation equal to 0. So let's subtract t, subtract 5. Whatever we do to one side, we'll do to the other. We'll subtract t and subtract 5. Okay, so everything here cancels out, and we bring down the 0. 0 equals t squared plus 5t plus 4. Okay, in order to solve for t, we can use a number of ways. I think the easiest one here is to factor this trinomial using the product and sum. So let's do that. This is t and that's t. I need two numbers whose product is 4 and whose sum is 5, and we know those are 1 and 4. And so we have two possible solutions here. T plus 1 equals 0. T plus 4 equals 0. And so in this case, t is negative 1. In this case, t is negative 4. But we know that we need to check both of these to see if one or both are extraneous. Okay, and it is possible that both could be extraneous. So let's try this. I'm going to check for negative 1 first. So what I'll do is I'll plug it into my original equation. And let me write the original equation here. Radical t plus 5 is equal to t plus 3. That was my original equation. So let me substitute negative 1. So if I substitute negative 1 for t, I'll have radical 4 is equal to, and then if I substitute negative 1 for t, negative 1 plus 3 is 2. And so radical 4 is 2 equals 2. That looks to be a viable solution. Now let's check the other one. T is equal to negative 4. Again, my original equation looked like this. T plus 5, radical t plus 5 is equal to t plus 3. So let's plug in negative 4. Negative 4 plus 5 would be 1, radical 1, is equal to negative 4 plus 3, which is negative 1. Radical 1 is 1, is equal to negative 1? No, that's not right. So this is an extraneous solution So your solution would be t is equal to -1. Okay, here's number 6. X minus 3 is equal to radical x minus 1. Pause the video and try this one on your own. Please check your work. Notice that you initially had two solutions, x equals 5 and x equals 2, and by going back and substituting these, we found that there's one viable solution, that's x minus equals 5, and that x equals 2 is an extraneous solution. Number 7. I have radical x squared plus 9x plus 15 is equal to x plus 5. My first step will be, of course, to square both sides to get rid of the radical symbol. X squared plus 9x plus 15 is equal to x squared plus 10x plus 25. So I will need to make this entire equation equal to 0. So I will subtract x squared, subtract 9x, and subtract 15 from both sides. Okay, 0 equals the x squared term is gone, and I have x plus 10. We'll subtract 10 from both sides, and this is the solution that we come up with. Okay, but remember, we need to go back and plug this into our original equation to see if this is a viable solution. So let me do this with a different color as I substitute -10 back into my original solution. So I would have radical -10 squared would be 100 plus 9 times -10, that's -90, plus 15 is supposed to equal -10 plus 5, which is -5. So when I simplify here, I have 100 plus -90 would be 10, plus 15 would be radical 25, is equal to -5. So we know that radical 25 is 5, and 5 does not equal -5. So in this case, the answer is no solution. The one solution that we got was extraneous. Work on number 8 on your own. Pause the video now, come back and check your work. Problem number 8. You should have gotten two solutions, positive and -3. And by going back to check, we learned that -3 is an extraneous solution. So the solution is x equals +3. For independent practice today, I'd like you to do number 3, 7, and 10. And then 6, 10, and 17. We will continue working on solving radical equations. Tomorrow, bring your questions. Get ready to practice this a whole lot. It does take a whole lot of practice. God bless you. Have a great night.